The next step to the winter night build is going to be the bipod. Just a reminder, this is the bipod that I'm trying to replicate, but I want to change a few things. One, I didn't want it all made of plastic, hence why I didn't just buy it off of Amazon for cheap. And the other thing I want to do is I want to have the aesthetic match what we're building. So either hexagons or octagons or some similar like angular feel. So the first thing that we're going to have to do is obviously we're going to have to design this thing. And what I basically did here is try and figure out how that mechanism works. I'm not going to model absolutely everything now because I want to do some prototypes and testing with my 3D printer first to make sure that all this stuff actually works before I put in the real design work to make this pretty. So let's start with it just being functional. And so what we have here is a flattened version of the M-LOK bracket, and we have our leg. And what essentially is going on here is this is the leg parts right here. So we have a little nub on the bottom of the leg, and you can see that there. So it's a nub on the bottom of the leg that locks into these octagonal little notches on our bracket. And the leg is going to have a spring-loaded slot here that keeps downward pressure on a screw that goes through the leg and threads into our bracket. And so if there's no one pulling on the leg, it snaps upwards and into place. And then if you want to move the leg, what you basically do is you pull it downwards, and you see how it slides inside that slot along that set screw in the center of the bracket, which takes that notch on the leg out of the octagonal slots, and then you can rotate the leg to go into any of the 5 angle locations as seen on the bracket. So that's how it's going to function. But let me share a little bit here. Let's take a look at what this stuff looks like in its angled version. So I went ahead and I angled this by 25 degrees. And the reason I did 25 degrees is because I want a total of 50 degrees of spread between the two legs. And what we're going to do is I've got 2 concerns with this design. One of them is going to be, well, does it work? And so that's obviously a big concern. I don't want to use expensive materials like my aluminum if I am not sure it's going to work. And then the other thing is I went and I tested how tall I like the bottom of my handguard off the ground when doing prone style precision shooting. And what I found was, depending on the surface, about 7 to 8 inches off the bottom of the handguard was optimal. That made for an extremely long leg, even longer than this. I didn't really love that concept. So what I did is I said, I'm going to cap it out at, I think it was 9 inches, 2, 4, 6, 9 inches long. So that it doesn't extend too far in front of the handguard when it's up. And if I spin them backwards, based on where I'm going to mount it on the handguard, it actually has clearance and it can fit in. I'm going to 3D print just this, the unpretty version, to test for functionality and to test for whether or not 9-inch legs gets me close enough to a comfortable feel of this bipod. Because if we got to go any longer than that, I'm going to start worrying about how it looks and also how the legs are stowed and whether they're going to get blast from the muzzle if I put them forward and all that sort of fun stuff. So test first. So here's our prototype put together. The concept is definitely valid. So it locks into position. I can't really turn this, a little tiny movement, but it stays pretty decently. And then what you do is that slot goes down, and now I can put it anywhere. I can lock it into the 90 degree, I can lock it into the 45 degree, and all the way at the other sides as well. So this is definitely a viable idea, but my rapid prototype has told me a couple things that I want to change. Look at the thicknesses of these two parts. This part versus this part and this part. It just looks odd. So even if it were structurally sound when milled from aluminum, it's just gonna look weird. So I'm gonna beef this up and I'm gonna beef this up. The other thing that I noticed is this is really short. I want to try and get a 1032 set screw in there that'll hold the spring, that'll keep this loaded. However, that's not going to allow for even a 1/4 of an inch set screw, much less a spring that'll allow you to compress it to that point. So we need to add some length here, and I don't yet know, I'll have to draw it out, if that's going to force me to elongate this section as well. So we will see. But good first rapid prototype. There are 3 main changes made to the design in preparation for printing out a second prototype. The first one is I doubled up the thickness of this section. It is now a 1/4 of an inch. This didn't quite get doubled, but I did make it look nicer and beefier. And I did add an extra 1/2 inch to the top of the leg, and I put a set screw hole to accommodate our screw and spring setup that's going to keep it spring loaded. I did not take a 1/2 inch off of the bottom of the leg. So yes, I understand that it's going to increase my material use, but that's fine as long as I'm not adding material to a side that will potentially impact my upper receiver or get out in front of the muzzle device and lead to, say, a muzzle blast hitting the tips of my bipod when it's not deployed. So what does this look like when it's actually set up? It looks like this. And if we take a look, it doesn't actually go below the surface of our M-lock bracket. So this is fine. I don't know if it's going to be aesthetically pleasing, but we will deal with that towards the end when I actually design the leg to make it look nice. This iteration was a great success. As you can see, we've got our spring in there. This is just a spring from a pen, so it's not very strong, but it's still. So I just need to make sure that I can get springs in this size that have a stronger pull. And when I used this and the previous prototype and I attached them to the handguard, it sat the handguard up off the ground, almost the exact same height as a Magpul bipod without any of the legs extended. So while that is the minimum of what I'd like to see, it's long enough. And like I said, I am worried about the length a little bit. So I'm probably just going to design for this length, give it a go, and worst case scenario, if I hate it, I can always just mill new legs.
Here you can see my final leg design. Lots of inset areas in thematically matching hexagon and octagon shapes. I've used different edge chamfers to not only cut sharp edges, but also add interest to otherwise boring areas. I tried adding more detailed features in the boring middle section, and it became too busy, so this was a nice compromise. I also plan to make some sections go all the way through the leg to spice things up as well. This design took me a lot of iterations before I felt it was right. Here you can see one of my earlier designs, which I had high hopes for, but it just didn't work out. Design is hard, it takes time. But you'll know when it feels right. It's a gut feeling sort of thing. Don't give up, keep trying. If you think you've got it right, take a screenshot. Make it your phone background. Live with it for a few days being constantly in your face. That's a good test to make sure you're happy. I also went and used this as a driver to learn Fusion 360, which is free for hobbyist use. I did this for two reasons. First, the 3D modeling functionality is much more built into the design aspect of using Fusion 360, so I was better able to visualize my design without additional work there over RhinoCAD. Second, I generally mill things on my CNC using VCarve as my CAM program. They are very vocal that they are not a metalworking CAM package. Therefore, they don't have adaptive clearing toolpaths, and they don't plan to add them. This became important to me as my first attempts at milling this using standard toolpaths and 1/4-inch bits wasn't going well. In the next video, we'll hopefully learn once and for all if that was due to the toolpath style or simply that my machine doesn't like 1/4-inch single or double flute bits in aluminum. Once I figure out how to add those different sized chamfers in the middle section, we're ready to mill.